morning. It's my pleasure to be here. I hope the next 40 minutes will be valuable to you. As Rob mentioned, I am the founder and leader of the Azure Sphere program at Microsoft. And I want to take you on a journey today. And that is a journey of how we're going to secure billions of devices around us. This journey began for me about 5 years ago. Somebody walked into my office with this floor plan. And as I looked at this chip, I realized I was looking at the 5th generation of computing. The first generation of computing, of course, was mainframes, then minis, then micros, which at Microsoft we call PCs, then smartphones, and the 5th generation was going to be connected microcontrollers. Now, and what was amazing to me about this chip was the first time I had seen a programmable microcontroller and a radio on a single die. And this chip is one that was actually designed at the behest of Microsoft to be used in our Xbox hand controllers. So it was intended to have a price of roughly a couple of dollars for this chip. Now, if you're not familiar with microcontrollers, I suspect most of you are in this audience, a microcontroller is a single chip computer. It's got processor, it's got storage, it's got memory, and it has I/O capabilities, all in a single chip. And usually for a few cents to a few dollars. Microcontrollers are found in many, many devices. There's over 9 billion microcontroller-based devices built and sold, deployed every single year. They go into everything from toys to home appliances to office, industrial, mining, agriculture equipment. They go into everything. In fact, my simple test for something that doesn't have a microcontroller is look at something if it has a status light and it does not have a color LCD, it's got a microcontroller. And that's, of course, if it has a color LCD, it's got a larger computer than that. Okay. Now, as I mentioned, we find these in many, many devices. And one of the things I realized that day as I looked at that chip was that every single microcontroller-based device on the planet was going to become connected. And let me give you an example. So let's talk about your refrigerator. All of you have a refrigerator at home. How do you know when the compressor in your refrigerator has gone bad? Well, today you know because you go home to find melted ice cream and spoiled milk. Okay? But imagine a future in which instead you find out that your refrigerator compressor is bad because you get a message from your refrigerator manufacturer. And it goes something like this: hey, you may have noticed that your fridge is making a funny noise. That's because your compressor is worn out. We're going to have a technician in your neighborhood this evening. Could we stop by and replace that compressor so that you don't experience any loss of the contents of your refrigerator? Now, which one of those refrigerators do you want to own? I'm going to argue you want to own the second one. I'm also going to tell you that every single refrigerator manufacturer on the planet wants to sell you that second refrigerator because it's an experience that delights their customer. When you don't have spoiled milk and you don't have melted ice cream, you're happy. And you are more likely to buy a refrigerator from them the next time around. Okay? And this is the beginning of what we call IoT. The democratization of network connectivity is the foundation of IoT, the Internet of Things. Now, IoT is not a technology revolution. It is actually an organizational revolution that is being powered by technology. And that's because IoT enables a digital feedback loop. It allows a company to understand what's happening with its products for the very first time. Think about the refrigerator manufacturer. For the very first time, they're able to actually connect with their customers around that device. So it changes the way they engage with their customers, changes the way they engage with their, optimize their operations, their products, and even their employees. It actually fundamentally changes the way all of these relationships work because you now have a digital connection that's easy in each of those relationships. Now, with this opportunity, as I thought about the future of literally every single microcontroller device on the planet being connected to the internet, Amazing opportunity. But I very quickly went to a second emotion. And that second emotion was fear. And that's because when you connect something to the internet, it creates a great deal of risk. What happens when you connect a device to the internet? Well, you create a two-way street between that device and the internet. Yes, the device can communicate out to the device manufacturer, but also hackers can come in through that exact same connection. Or as my friend and former colleague James Mickens, who's now at Harvard, likes to say, the internet is this cauldron of evil. And you've now created a connection between your refrigerator and a cauldron of evil. Now, you've probably all seen headlines about IoT devices being hacked. Refrigerators sending spam, baby monitors being used to spy on families or even project messages into homes. But I like to use, I think one of the most illustrative IoT hacks was the Mirai botnet attack. The Mirai botnet attack occurred about 2 years ago. And what happened was a group of hackers took over somewhere on the order of between 50 and 100,000 everyday appliances. And they took them over and turned them into a botnet. They used that botnet to launch a distributed denial of service attack against DYN. Now, if you don't know DYN, they're the major DNS namespace provider for the United States. The effect of this attack was to knock the entire east coast of the United States off the internet for a day. No chat, no Facebook, no Twitter, no shopping, no online video. Frankly, I don't know what anybody on the East Coast did that day. Okay? And ironically enough, by the way, most of those devices that were taken over by hackers were security cameras. Okay? Now, so how do you build a secure device? If you know there's going to be hackers out there, they're going to be coming in and attacking your device relentlessly, how do you build it? Well, this is something that we at Microsoft have quite a bit of experience with. I've been at Microsoft over 22 years, and my entire career has been spent working on internet security of one form or another. We've been detaching devices to the internet for decades now. You name an attack, we've experienced it. Okay? I want to introduce you this morning to one of the most secure devices Microsoft has ever built. It's called the Xbox One. Okay? And you can think about it. Well, this is a device that runs in a very hostile environment. It needs to protect the privacy of the home that it resides within, but it also needs to protect the content that's on that device from hackers, okay? And very determined hackers. We've learned a lot from that. We've learned a lot from all of our other devices and from PCs and all the other arenas in which we've played. One of the most important things we've learned is that security is foundational. You have to build it into the device from the very beginning. It has to be part of your thought process. It has to be part of your design process. As I began building out at the Azure, what became the Azure Sphere program, one of the things we did, we collected all of the wisdom that Microsoft had acquired about how to build secure devices, and we published it as a paper. It's at that URL, ak.ms/7properties, the 7 properties of highly secured devices. And I use this term properties very specifically. A property is something you can measure. This isn't the 7 good intentions of highly secure devices. It's the 7 properties. There's a set of questions in that paper you can ask about any device and say, does this device have high enough security that I feel like I can connect it to the internet and have it be connected for a decade and still feel like I'm safe? Now, as we look through the 7 properties, some of the properties are purely hardware-based. An example of that is a hardware-rooted trust. A hardware-rooted trust provides you a way to uniquely identify a device that can't be subverted, to verify that the device is actually running the software that you intended it to run, for example. Others of the properties require hardware and software working together. An example of this is defense in depth. Now, defense in depth is actually one of the oldest principles of security known to man. We see it in castles, we see it all over the place. And it's the idea of having additional layers of defense so that if an attacker is able to breach a first layer of defense, you have additional layers of defense behind that. In a device, defense in depth requires both hardware that knows how to create barriers and software that knows how to configure those barriers. Now, you might be, if you think about building a device, you might be right now thinking of this question, but Galen, how do I know when someone sells me security technology if they're selling me snake oil or the real thing? Okay, I'll give you the one question you can always ask and you will know whether you've got someone who really knows about security or not. You say, okay, I understand your security technology, but tell me, how does it help me when an attacker gets into my device? Because if someone has experience with attacking, they know that any device is susceptible. Ultimately, a determined hacker will get into a device somehow. And the question is, do you have enough layers of defense in depth to stop the attacker in their tracks and be able to kick them out and be able to take your device back over? Finally, some of the others of the 7 properties require hardware, software, and cloud all working together. An example of this is renewable security through software update. For that, you need a cloud that can provide the latest version of your software. You need software on the device that knows how to take that update and apply it robustly, reliably onto the device. And you need hardware that prevents an attacker from rolling back to a previous version of the software. And here's what happens. This was something we learned through hard experience. Let's say you have version 1 of your software is out running on your device. And somewhere you figure out, oh, there's a security vulnerability. Maybe a new kind of threat emerges. Maybe you figure out there's a bug in the device. But you figure out, hey, there's a security vulnerability. We need to release version 2 of the software for the device. And we want to get that out on all our devices. And you do that, and it's out there. Well, what hackers have figured out long since is that if they can trick a device into rolling back to run version 1 of the software, they can use a known vulnerability. And so you have to have support in the hardware to prevent that. Now, meeting the 7 properties is difficult, it's time-consuming, it's costly. And it requires 3 fundamental expertise that very few organizations hold. Let me explain. So first, well, you've got to have really good engineers that know how to build a highly secure device. And those engineers have to know how to take all the various aspects of security, all the various technologies, and weave them together correctly. And that's because if they don't, your security is only as strong as your weakest link. I'll give you an example of this. When we do communicate across the internet, we use secure cryptographic algorithms. And the foundation for using those algorithms on any specific communication between 2 parties requires what's called a nonce. It's a random number that is used to secure that particular communication. Well, if you have a very poor nonce random number generator, or an adversary can trick your protocol into loading a nonce of their own providing, they can circumvent your wonderful, powerful crypto algorithms with a very simple side door. Okay? So you have to have amazing security engineering to make a device secured at the day that you ship it out door. Well, the problem is, when you're building a device that's connected to the internet, your problems don't end the day that you ship that device to your customers. Your problems begin the day that you ship that device to your customers, because that's the day that the hackers begin attacking it. So the second thing you need is you need security expertise ongoing throughout the lifetime of the device so that you can understand, as new threats and new vulnerabilities emerge, how to address them with your device. And one of the things I'll say is new threats do emerge. Hackers are very, very creative, and every time, and there's new generations of hackers coming, they will come up with new ways of attacking devices that no one ever considered before. My favorite example of this is we used to, on PCs, we assumed that RAM was safe, that you could store secrets in RAM because the RAM was only viable as long as it had power. So someone couldn't take RAM out of a PC and move it to another PC and steal your secrets. Then somebody figured out that, well, if you spray DRAM with Freon, it lowers the temperature enough that you can actually pick a DRAM SIM out of a PC and move it to another one, and all the bits are still in place. Okay? Who thought? Well, that's the way security works. You have to keep having new mitigations against new attacks. Now, the third expertise you have, so let's say you figure out there's a new kind of attack, you create a software update. Well, now you've got to be able to deploy that out onto every single one of your devices. So you have to have the logistics, infrastructure, and operational excellence to be able to deploy that update to all of your devices globally, sometimes in a matter of hours. This particularly happens with what we call a zero-day exploit. This is someone figures out a vulnerability, and before anyone knows that that vulnerability exists, other than the attacker, they've already weaponized it and put that digital weapon out on the internet attacking your devices. When that happens, your customers are under attack, or you're under attack. And so you've got to be able to update those devices as quickly as you possibly can. So these three core expertise, sound engineering, amazing engineering, security expertise to analyze new vulnerabilities and new threats as they come out and figure out how they apply to your device, and operational excellence are all required in order to build and maintain a highly secure device. Now, you might be thinking, hey, my device has maybe 2 or 3 of those 7 properties. Isn't that good enough? Maybe it's even got 5 or 6. My answer to you is no. Here's what we've learned with the Xbox. The very first generation of the Xbox, the original Xbox console, when it was introduced, it had 2 of the 7 properties. It was based at the time on the very best PC class security. 2 of the properties. That device was hacked for the very first time 3 weeks after we shipped it. Okay? So we went back to the drawing board. We spent a lot of money, in 8 digits, I guess. A lot of money building custom silicon for the next generation of the console, the Xbox 360. The Xbox 360 had 6 of the 7 properties. Now, 2 of the 6 were a little weaker than we would like, definitely weaker than we know we need now, but it had 6 of the 7 properties. That device was hacked for the very first time 3 months after it shipped. So we bought ourselves, what, about 11 weeks? 9 weeks? I guess we bought ourselves about 9 weeks, okay? With the Xbox One, that device, we took everything we knew about security and put into that device. It has been on the market for over 5 years, and it has all 7 properties, and it has not yet been hacked. Okay, now I use that word yet. We always know there's the next clever hacker who's out there, okay? Now, you might be thinking, great. If you're building a device that's got hundreds of dollars of electronics, you can afford to put in all of the security that's needed to make a device that's secure enough to be out on the internet. But what if I'm building just something like a simple temperature sensor? Do I really need all of that security? Okay, I'm here to tell you, yes, you absolutely do need all of that security. I'm going to tell you a story, and you're going to think that this is the next sequel to Ocean's 11. But it really happened, and it really happened here in Vegas. One of the casinos here in Vegas has a large fish tank, a large aquarium, or a fish tank in their casino. And somebody bought a connected thermometer to put in the fish tank so that they could monitor the water temperature remotely of how that fish tank was going. And of course, whoever built that fish tank thermometer thought, why would security matter on a fish tank thermometer? Okay? Well, hackers, and let's see, so they Didn't put a lot of security into it. Hackers were able to take over that device, and they used it as a foothold. They were now inside the casino's enterprise network. And they could be in there as long as they wanted because they owned a device inside that network. And they, from that thermometer, they scanned the entire network. They found the high roller database. They attacked the high roller database, and they extracted the contents of the high roller database, pulled it out through the thermometer, and out onto the internet. Okay? And if you're a casino, the only thing more valuable, well, your most valuable thing, of course, is the cash in the vault. But the second most valuable thing is the high roller database, all because of a fish tank thermometer. Okay, now I'll go back and talk about microcontrollers just a minute. Think about where microcontrollers are deployed. If you have a gas heater furnace, your family depends on a microcontroller to make sure you're not poisoned by carbon monoxide. Your car, you depend on a microcontroller to make sure that your airbags don't explode at the wrong time. You depend on a microcontroller to make sure that your anti-lock brakes go off at the right time and in the right coordination. In your home, you depend on a microcontroller in your refrigerator to make sure that your refrigerator isn't incubating botulism. Okay? Every single device matters, and it matters because the context matters. It's there to protect your enterprise, it's there to protect your home, etc. Okay? Well, so how are we going to secure the billions of devices that are being deployed? These 9 billion new MCU devices that are built every year. How are we going to secure them? You might think it's impossible. I'm here to tell you it's possible and it's practical, and I'm going to give you an existence proof. That existence proof is Azure Sphere, the product my team has been working on for the last 5 years. Azure Sphere is an end-to-end solution that allows any device manufacturer to build a highly secured device and keep it secured throughout its lifetime by outsourcing the hardest parts of security to Microsoft. And there's 3 components of an Azure Sphere. The first are Azure Sphere certified chips, hardware. The second is an operating system that runs on those chips. The third one is a cloud service that interacts with the devices and keep them protected throughout their lifetime. I'm going to drill into each of these in just a little bit of detail. So first, Azure Sphere certified chips. These are chips that have built-in hardware root of trust that is certified and created from Microsoft's learnings as we secured 3 generations of the Xbox consoles. Drill in a little bit. So each Azure Sphere chip starts off looking like any other microcontroller. It's got a real-time processor, has I/O capabilities. To that, we add internet connectivity. The very first generation of chips are Wi-Fi. And then to that, we add a hardware root of trust and internal firewalls, defense in depth in the hardware level. And they also have richer processors that enable new IoT experiences. The second component of Azure Sphere is the operating system. What we've done with the operating system, we built an operating system for these chips that combines the very best of Microsoft's technology and learnings from the Windows experience with open source technology to build a trustworthy IoT software platform. It is a multi-layer defense in depth operating system, one layer after another. The first layer runs on the device. It protects the keys and controls the booting of the processors. The second layer provides guards in the integrity of the chip and access to hardware resources. The third layer is a custom Linux kernel. Yes, you heard it right. Microsoft is building an operating system with a Linux kernel. We've taken the Linux kernel, we've optimized it for IoT, and we've made significant security enhancements to it. Okay? And we chose to use a Linux kernel because we want to enable any device manufacturer to build an Azure Sphere-based device. And we want to enable any chip manufacturer to enable Azure Sphere on their chip. And the easiest way to do that is to open source the layer of the chip, the layer of the operating system that they need to customize for their silicon. The layer above that is a set of on-chip cloud services that provide authentication, update, and secure connectivity. And then only at the very top layer is where we run the code of the device, the application we call it, in secure containers. And the idea there is that if something goes wrong in the application, we still can protect the entire rest of the platform. Now, the third component of Azure Sphere is the Azure Sphere Security Service. The Security Service guards every single chip on the planet. It brokers trust between that chip and other devices. It detects emerging security threats, and it provides software updates. So the security service protects the devices by providing certificate-based authentication. So there's no passwords on these devices. It detects emerging security threats by monitoring what the behavior of the device, and when there's something abnormal happening on the device, sending a report that we then process with machine learning to figure out what's going wrong. How is an attacker attacking the device? Then we create updates, and we respond to those attacks by pushing updates out onto the device. And finally, the security service also empowers device manufacturers with hands-free deployment of updates of their software that runs on the device, so that they can provide new features over time and enable new customer experiences. Now, device security is like a stool. It requires 3 legs: hardware, software, and cloud working together. And if you take any one of those legs out, it doesn't work. The security doesn't work. Now, I want to give you one example of someone who's using Azure Sphere in deployment right now. Azure Sphere has unlocked IoT for Starbucks. I assume people in here have heard of Starbucks. Okay, all right. Ironically enough, I don't drink coffee. I've never had a cup of coffee my entire life, okay? So I did not bond with the Starbucks engineers around coffee, but I did bond with them around security, okay? And here's the simple way I'll describe it. Starbucks wants to make sure that when you come in to have a cup of coffee, that you have a fantastic experience, that you can get exactly the cup of coffee you want with exactly the features you want, and that they can roll out new recipes periodically, et cetera. Well, one of the obstacles to that are the actual espresso machines themselves. They're mechanical devices. They wear out. They experience failures. And so Starbucks wanted to be able to actually monitor all of their espresso machines online, okay? Now, in order to do that, they need network connectivity. But they need security. And that's because Starbucks understands that the worst possible thing that could happen to them was, imagine a Monday morning when every espresso machine in every Starbucks store worldwide is held ransom by attackers, okay? That's not just a financial problem, that is a societal collapse, okay? And they don't want that to happen, okay? And so security is paramount to them. Well, we went to them, they heard about Azure Sphere, we introduced it to them. They said, this is fantastic, we love it, but we have tens of thousands of espresso machines in deployment. We can't go replace all of them right now with new Azure Sphere-based espresso machines. And so what we figured out, we got together with them, and we built what we call a Guardian module. And there's a picture here. And a Guardian module is about the size of a deck of cards, because we're in Vegas, right? And it connects onto the side of an existing legacy device. It's what we call a brownfield deployment. Connects on that legacy device, uses whatever debug ports or other information is available on the device, and then it connects securely to the cloud using Azure Sphere. And so Azure Sphere, in that way, with this Guardian module deployment, what we found is we can take any existing deployment equipment, any equipment in your factory, any equipment in your store, et cetera, and connect it securely to the internet using Azure Sphere. All right, I talked about the opportunities of IoT. I talked about the risk. I want to introduce one more word, and that word is responsibility. We all have a shared responsibility to make sure that as the world moves into a fully connected IoT world, that the devices that are out there are secured, okay? If you make chips that go in devices, my call to action is you need to make sure that those chips have security in them, okay? If you make devices that will connect the internet, my call to action is make only highly secure devices. Go read the 7 properties people. And if you don't make devices or chips, but you buy devices, and you will, that have connectivity in them, make sure that the devices that you're buying have all 7 properties. I don't care if they have Azure Sphere in them or not. What I care about is that they're highly secured, because we want to live in a highly secured future. Let's secure the future. Thank you.